Hi, in this video, I'm going to talk about introduction to EIGRP. Okay, EIGRP stands for Enhanced IGRP, which is Enhanced Interior Gateway Routing Protocol, a Cisco routing protocol. There we go, get rid of that little message there. Cisco proprietary routing protocol released back in 1992. EIGRP has some of the features found in a link state routing protocol, but it is definitely a distance vector routing protocol, not a hybrid. There was a time when they used to call this a hybrid routing protocol, meaning hybrid between link state and distance vector, but it is purely a distance vector routing protocol, not a link state. In 2013, Cisco released an informational RFC for EIGRP, and that means that it is available for other vendors to adapt the protocol for their equipment. However, Cisco retains the technical rights to the protocol, meaning they're the only ones that can make any enhancements and that sort of thing. So Cisco actually controls and still continues to maintain control over EIGRP. Okay, just show you a little bit of the timeline there with a lot of these routing protocols, including EIGRP. EIGRP was released at a time when RIP wasn't really a preferred routing protocol for many environments. And some people were just a little cautious about ISIS and OSPF, not because anything technical, just because of the requirements and not maybe fully understanding a link state routing protocol. So Cisco came up with EIGRP to replace their IGRP routing protocol. It's also a classless routing protocol where IGRP was class full. I won't get into that, but it just when we moved away from class A, B, C addresses, a classless routing protocol, just since I've kind of gotten into it, is a routing protocol where the subnet mask is advertised along with the network prefix. That allows you to have any size mask with any size with any size mask with a prefix. Classful routing protocols, you have to have class A, B, or C /8/16 or /24 network address. All right. So some of the key EIGRP components: protocol-dependent modules, reliable transport protocol, neighbor discovery, and dual. We're going to talk a little bit about PDMs and RTP right now. We'll talk about neighbor discovery in a later video and also dual in a later video. But protocol-dependent modules. EIGRP maintains individual tables for each routed protocol, like IPv4 and IPv6, like a neighbor table and the topology table that we'll see in a moment. EIGRP uses these things called protocol-dependent modules to provide support for different routed protocols, layer 3 protocols. Today we think of these as we deal with just IPv4 and IPv6, but back in the day, routed protocols also included Novell IPX and Apple's AppleTalk. So each PDM is responsible for the functions of that specific routed protocol. So you can see here we have separate neighbor tables for IPv4 and IPv6, separate topology tables, and those lead into separate routing tables. Okay, RTP, Reliable Transport Protocol. By the way, RTP is an acronym for other types of protocols like real-time protocols, but in this case, it's Cisco's Reliable Transport Protocol. So as you can see here, the IPv4 and IPv6 EIGRP protocol-dependent modules that are at the top here are carried over a transport layer protocol called RTP, which is Cisco's transport protocol, not UDP and not TCP. And then that is encapsulated over IPv4 and IPv6. Excuse me. We'll see that not all packets are sent reliably, meaning that not all packets are acknowledged. We'll get to that in an upcoming video. So why did Cisco use RTP? Well, back in the day with IPX and AppleTalk, those protocols didn't use UDP and TCP, of course, because they were not part of the TCP IP protocol suite. So Cisco created their own transport protocol called RTP. And we'll see how that works a little later. Okay, but just a few basics on it. I said that there's both reliable and unreliable packets in RTP. Reliable packets are those that require an explicit acknowledgement from the destination. So if a router sends an update, a query, or a reply, it expects an acknowledgement in return, just to know that the other end, that the neighboring router received that packet. Unreliable packets do not require an acknowledgement. Those include hello and acknowledgements. And we'll be talking more about these a little later. So RTP can send EIGRP packets as unicast or multicast, depending upon the configuration. But we'll talk about a little bit about this in later videos. But over IPv4, the multicast addresses you see there's 224.0.0.10, and IPv6 EIGRP multicast address is FF02, which is the IPv6 multicast, :A, which is the same as 10 in decimal. Okay, EIGRP also does authentication of the routing updates to ensure that, that these updates are from a legitimate source. Okay. Another feature of EIGRP we're going to be talking about much more in a later video is that something called dual. Cisco uses the diffusing update algorithm, and we'll talk much more about this in a moment, but just want to mention that J.J. Garcia, who's a distinguished professor at University of California, Santa Cruz in computer science and engineering, he is the developer, main contributor to dual algorithm, and somebody I teach with up at UCSC. A brilliant man, excellent professor, and just a really, really great guy. So I'd like to give credit where credit is due. With dual, we'll see that EIGRP does not age out routable entries like RIP does. Doesn't have a timer where routing updates is only good for a specific amount of time. So it does not use periodic updates. We'll see that dual maintains a topology table separate from the routing table, includes something called the best path and loop-free backup paths, if any. Now, this isn't going to make much sense right now, and that's okay. We're going to talk much more about dual in a later video. Okay, but it does offer fast convergence, also equal and unequal cost load balancing, and these are just these are other features of EIGRP, what we call partial and bounded updates. Okay, so just some of the features of EIGRP. All right, we'll be talking much more about EIGRP in later videos.